So now the property which does not allow the formation of lather with soap is known as hardness. And this hardness is because of various salts of calcium and magnesium. Main points are salts of calcium and magnesium are responsible for hardness, and these salts will lead to lack of formation of lather with soap. These points must be there when you're writing what the definition of hardness is. So now next is the two types of hardness. Now two types of hardnesses that we know are temporary hardness and permanent hardness. So now temporary hardness, as the name suggests, the hardness can be easily removed by basic methods. So now what are the salts which are responsible for temporary hardness? So as I've told you before, always calcium and magnesium cation will be present. It is just the anion which differs, and then the type of hardness causes also will change. It's the anion which decides. So now let's take Ca2 plus, which is a calcium cation, and then we'll replace this with an anion as well, so that you can form a proper compound. So now CaHCO3 twice, MgHCO3 twice are supposed to be the most common salts which are responsible for temporary hardness. Few textbooks will also have calcium carbonate and MgCO3 as well. These two salts also will be present. No, you can probably check with your teachers and then write if this is also correct, but then majority of the textbooks will just have these two salts, which is calcium hydrogen carbonate or calcium bicarbonate, or magnesium hydrogen carbonate or magnesium bicarbonate. These two are the most important salts which are responsible for temporary hardness, and then calcium carbonate, magnesium carbonate are also responsible at times. So this can be referred once and then it can be written in your exams. So temporary hardness is caused because of these two salts. Next one is supposed to be permanent hardness. So now what is permanent hardness? So permanent hardness is supposed to be such type of hardness which cannot be removed by easier means, like how which is followed for temporary hardness. It cannot be removed. So now what are the salts which are responsible? So it is generally the chlorides and sulfates of calcium and magnesium. That is a generalized format. So it can be MgCl2, CaCl2, MgSO4, CaSO4, and these are supposed to be the most common salts which will cause permanent hardness. And permanent hardness, as the name suggests, and as I told you right now, it is permanent. That means you need a better method rather than the methods that you follow for temporary hardness. So what are the methods that you generally follow to make sure that a temporary hardness is removed? So the methods that you generally follow to make sure temporary hardness is removed is heating, just mere heating of this compound. And apart from that, next is nothing but Clark's method. So first one for temporary hardness for removal. So let me just draw an arrow here and then write removal. So now for removal, I'll write it here. For removal, you have two ways. So one is supposed to be Clark's method, and the second one is supposed to be heating. So you have Clark's method and then you have heating. So now what is Clark's method? Clark's method is nothing but the addition of lime. So now many textbooks, there'll just be a phrase which says addition of lime, but then the actual name for it, you might have learned in the CBSE syllabus as well. So Clark's method is the name for it. So now let us just write few equations, and then we'll know how hardness has been removed, how the temporary hardness has been removed. So now the first way, as we discussed before, is nothing but heating. So now let's take calcium hydrogen carbonate or calcium bicarbonate, and on heating what happens? You will be getting CaCO3 and then you will be getting H2O. We'll be getting CaHCO3 on heating. You'll be getting CaCO3 and then you will be getting H2O as well. And apart from that, you will be getting CO2 because this HCO3 twice. So obviously you will be getting CO2 as well. And this CaCO3, which is calcium carbonate or limestone, is supposed to be an insoluble salt. It comes out as a precipitate. Since this comes out as a precipitate, it can be easily removed. So your temporary hardness is completely removed. The salt, which is the trouble, has been removed. So this is nothing but by mere heating. And then next one is supposed to be Clark's method. Clark's method says when you have CaHCO3 twice, and then when you add your lime is nothing but CaOH twice. When you add that, you will be getting CaCO3, and after adding you will be getting 2 CaCO3. Okay, 2 CaCO3, and then you will be getting H2O as well. Again, you are supposed to balance it, 2 H2O. So now when you add lime, you will be getting the same calcium carbonate, which can be removed because it comes out as a precipitate, and then you'll be getting water as well as a byproduct. And here on heating, you'll be getting calcium carbonate. Let's just check the balancing. Calcium carbonate, you'll be getting H2O and as well as CO2. And then this CaCO3 can be removed because it is insoluble, and then it comes out as a precipitate. So you can easily remove, and you know why it's insoluble. You must have learned it in 11th grade. So this is the way in which you remove temporary hardness. And now next one is permanent hardness. There are a lot of methods which you will be learning in the subsequent videos, which is permitted process, or which is also known as zeolite process, ion exchange process, and then Calgan's process, and there's a lot of processes. You will be learning everything in detail in your upcoming videos. So for permanent hardness, you have a various amount of processes which is classified in a huge way. So we'll be doing that as a new concept. In the subsequent videos, part by part, we'll be doing it. And then for temporary hardness alone, it is nothing but heating. That's the first way. And second way is Clark's method, which is addition of lime. So addition of lime is the thing which you do. So before I wind up in this video, I would like to mention one thing. Remember, we were talking about this fact that lather with soap will not be produced if the hard water reacts with soap. We learned it. So now everyone must have a question on why. Like, what is the chemical reaction which is responsible for this? So now this we must have learned it in the lower classes itself. Anyways, let it be a short recap for it. C17H35 COONA. This is supposed to be the chemical which is most commonly present in soap. And then you know the most common cation which is present in the salt, which is responsible for hardness. You know that. So when this cation of the salt reacts with this sodium stearate, which is a chemical which is predominantly present in soap, so it forms C17H35. This the reaction. And anyways, you're not supposed to write the reaction like this. It should be in a straight line. So C17H35 COO twice Ca plus Na. So depending on your cation, everything changes. So now it's Na plus. So now in case depending on your anion, everything changes. I must have said cation. So for example, with calcium sulfate, here will be Na2SO4. In case of calcium chloride, it can be 2NaCl. After balancing, you can it will be 2NaCl. So now this Na plus can be the charge can be balanced with the anion, which depends on whatever anion is there in the salt.